all of you switch on your videos. So good afternoon, Subhashish sir. Am I audible to you?
Yeah, I can hear you.
Thank you for joining this webinar series for the students of Bajaj Science Center Wardha. Right now we have 50 plus kids who will witness this webinar from you. So on behalf of Bajaj Science Center, I welcome you for this webinar. It's my privilege to introduce kids that we have one more eminent physicist, young physicist from this region, from Vidarbha. You will listen him today for a very popular topic that is the history of atom. So Subhashish Chandra sir is working with the Institute of Forensic Science as an assistant professor, and rest he can tell about him. So I request Subhashish sir to start the session.
Good afternoon, everyone. I hope I am audible to you. Govinda is more of a brother than a junior. We are from the same college and we went to the same university. He went to a different college though. And we used to meet, and it is an honor to meet you people because you are the young brains and the young minds who are going to take this country forward. Without making much ado, let's move on to today's topic. I believe all of you must have heard about atoms. Govinda, can I share the screen from my end?
Yes, yes, sir.
Okay. So, as the atom story goes, the first thing is, why should we know about the story of the atom? Why it is so important? Well, when I was a kid, I used to watch a movie called Chhadobeshi in Bengali. And you might have seen it in English. It's called Chalte Chalte. Sorry, not Chalte Chalte, Chupke Chupke. Now, in that, there was a character who was a physicist, as me and Govinda are, and I hope many of you will be in the future. So, whenever his girlfriend used to ask any question about anything, he used to say, we have to go to the basic point where everything started. Because we all are made of atoms, so we have to know about atoms. And today also, we are going to look into that hero's statement that we have to look into atoms because you are made of atoms, I am made of atoms. The things that you are holding right now are made of atoms. And let us find out what atoms is. Well, the story of the atom started with this fellow over here. His name is Democritus, and he used to live in ancient Greece. And as you might have heard about few ancient Greek people like Socrates, Plato, or Aristotle, these people were fine philosophers, fine mathematicians, and many of them were fine physicists as well. Well, Democritus was not a scientist per se, he was more of a philosopher who gave a philosophical definition to the atom. He said that every thing is made up of small, physically but geometrically indivisible particles. He named them atoms, which was on a Greek word atomos, which means that which cannot be split. And he gave few characteristics. He said that there are infinite number of atoms. He said different substances are made up of atoms. By that he meant that glass is made up of glass atoms, wood is made up of wood atoms. This is something which we don't follow right now, but in 4th century BC, this was a very big concept to say that glass is made up of just glass atoms. The different atoms differ in size, shape. There is an empty space between the atoms. This is also acceptable now. The atoms are indestructible and the atoms are always in motion. So Democritus gave the first few principles of atom, which was quite new at that time. But his principles met another fellow, a very famous Greek fellow called Aristotle. Now this Aristotle is the student of Plato, and he was the teacher of the famous Alexander the Great. And Aristotle had a say on everything. He once declared that women don't have much intelligence because their cranium capacity is less. And he used to advise everybody about everything. So he had something about the atom also. Unfortunately, he never believed in the theory of atom. Whatever Democritus was saying, he didn't believe in that. And he theorized that all the substances are made up of 5 things: earth, water, air, fire, and ether. He said that earth comprises of anything which is cold and dry, water is cold and wet, air is hot and wet, fire is hot and dry, ether is a divine substance. Well, you can compare it to our own Panchabhut also, but it was a little different, and Aristotle was very strongly in belief about all these things, and the people around him also used to follow him, and they stopped believing in poking into the atom and rather believe that whatever Aristotle is saying is correct. And this entire concept of atom was done and dusted away, and it remained so for the next 2000 years. For the next 2000 years, there was nothing called atom. Nobody was caring about it. And then this British gentleman, his name is John Dalton. He was a chemist by profession, and it is said that he was color blind. He couldn't see few of the colors, possibly the color red. Now he said that elements are extremely small masses, and he also called them atoms. The same name that Democritus has given, he also called them atoms. He said that atoms cannot be subdivided. Atoms of a given element have same mass and same properties. Atoms of different elements have combined in whole number ratios. In a chemical reaction, atoms can be separated or rearranged. Now, this atom that John Dalton gave is the first atom that you are always going to encounter in your textbooks. So these are the first atoms that you are going to encounter in your textbooks, because this is where the story of the atom actually begins. This is the story of the modern atom, which we all see. Most of the things that you are reading over here are almost true. Few of them have changed over the period of time, but it is the base from which we all started understanding atom. And as young kids, you will also start understanding atom from this very point of time. He also called this model as the billiard ball model, as he thought that the atoms are solid hard spheres like billiard balls. Now, as we will go forward, you will find out that the model doesn't look like this anymore. But if you have gone to the Bajaj Science Center and if you have seen the model of the atom, you will still find the electrons and the protons and the neutrons as hard spheres. They are not exactly looking like how they should be, but they all look like hard spheres. And somewhere or the other, we do believe that hard spheres are the easiest to represent, and that is what John Dalton did. I believe Govinda will also accept with me that his models also have these hard spheres. The hard spheres will give away in the due course of lecture. Now, when he gave this model in 1803, there were 36 known elements. I believe now the number of elements have reached somewhere around 118 or something. I don't remember. I think it's 118. So the 36 elements that were known during that time, he characterized all of them. He gave different symbols to them. And according to him, if you have such atoms of element X, let's say, and such atoms of element Y, then they can be joined together in the simple whole number ratio, and such compounds can be formed. When you will study chemistry in later classes, the initial chemistry that you will see will follow this model that we are seeing right now. Now, in 1803, we revived the atom back, and a lot more work was going on at that time. We can say that the golden period of experimental physics, it started from this time itself. Lot many good scientists came in during that time. If we study later on, you will find lot more work going on in electricity, magnetism. That in that time you might have heard about scientists like Michael Faraday, Ampere, whatever the new units that you are seeing right now, the experimental units, all belong to that period. And everything was going in mostly in two countries, and that was Germany and England. So it was in due course that a British physicist, his name was Joseph John Thomson, he was the man who was working with electricity in this kind of a tube. Now this tube in those days was called the Leonard tube, because a German scientist called Leonard had discovered this tube. This tube, from the left you can see that there is a cathode in which you provide electricity and it will start emitting electrons, and the anode will attract them. Then there is a magnet and a battery which will deflect it on some side. In those days, the rays were called the Leonard rays or the cathode rays, and they were visible. Now, thank you. Now, when Thomson was studying this model, he found out that the beams were getting deflected towards the positive charge and were getting repelled away from the negative charge. So he concluded that whatever this ray is, whatever its constituents is, it has something to do with negative charges. And he said that yes, the charge is negative in nature, and he was able to find the Q by M ratio, that is the charge per mass ratio of the particle. Now, he also found out that these particles were traveling much farther than he thought so. And the cathode rays were about 1000 times lighter than the hydrogen atom, whose mass was known at that time. So we have a particle which is negative in charge and which is very, very light, about 1000 times lighter than the hydrogen. And he said that these particles should be called corpuscles, and they are negative in charge, and the mass is 1000 times lighter than the hydrogen. But later on, these particles were not called corpuscles. You might have not heard about corpuscles. Now the word corpuscle has been replaced by the word electron, which was suggested by an Irish fellow, George Stoney. Depending on this, he gave a different atomic model. He said that the atomic model should be like a plum pudding. Now, if you, or you can say a choco cookies cake, or you can say a watermelon, in which the red portion, well, or the cake wala portion, is a big positive charge, and the electrons of choco cookies or the watermelon seeds spread over it. So this model was called the Thomson atomic model or the plum pudding model. He received the Nobel Prize in Physics for the year 1906. This was the first of the many Nobel Prizes that this field is going to see. Let me tell you one motto behind choosing this topic for today's webinar is to encourage you in a field which has seen lot many Nobel Prizes for innovation and for making people understand. This is the next fellow, Ernest Rutherford. Well, Ernest Rutherford was a thorough gentleman, and if you follow cricket, I don't know if you have seen Richard Hadley of New Zealand. Ernest Rutherford generally looks like him. Ernest Rutherford was a New Zealander who used to study in McGill University, Canada. And from McGill University, Canada, he came to Cavendish Laboratory, Cambridge. And he was a student of J.J. Thomson, who discovered the electron. And Rutherford, with Hans Geiger and Ernest Marsden, developed a very famous experiment. This experiment actually earned him a very famous statement by Encyclopedia Britannica, the father of nuclear physics, the best experimental physicist to be born after Michael Faraday. Now, in this experiment, which we are going to see in the next page, on the left, you can see that there is a radioactive source which is emitting alpha particles. In the center, there is a gold foil. The alpha particles will strike the gold foil, and it was assumed that most of the alpha particles should come back because alpha particles are positive in charge. The Thomson atom was positive in charge. The Thomson particle was, the Thomson atom was positive in charge mostly, and hence he thought that the alpha particle will strike and come back. But as you can see in the figure, most of the alpha particles have gone through the atom. Only few alpha particles have come back deflected. So this shows that the atom is not what it was supposed to be. The atom was basically empty. The atom was basically empty, and it had vast amount of empty space. I believe if you take the model, if you are in Wardha, then the next particle will be somewhere around Nagpur. That much empty it is. So if we increase the atomic model to the size of your cities, so if you stay in Wardha, the next particle in the atom will be in Nagpur.
Is there any animation?
Simple, a text will come out. It was coming out till now. Kapish Lakhotia.
Sir, I think somebody is doing it purposely.
Somebody is doing it purposely?
Just a minute. I'm connecting you back.
So,
Thank you.
So
it was observed that most of the particles were not deviated, and as you can see, most of them went through, few of them were deflected back. So as alpha particles are relatively fast and they are heavier, only a strong positive field can produce such kind of deflections. Also, most of the alpha particles, since they went through, indicates empty spaces. When Rutherford was asked, he said that it was as if a 15-inch shell from a shotgun was fired onto a tissue paper. And instead of going through the tissue paper, the shell came back at you. But most of the other bullets actually went through. He gave this kind of a model which had a positive and other electrons orbiting around it. This model at that time was called the planetary atomic model. The radius of the atom was found out to be about 10 to the power of minus 10 meters, which is about 10 nanometers. Using the experimental results, it was found that the nucleus was about the size of 10 to the power of minus 14 meters. That is, if you convert it into meters, and if the nucleus is of the size of 1 meter, then the electron is at 10 to the power of 4 meters. That is at 10 kilometers away from there. Okay. Now, Rutherford didn't stop at that. He also discovered the proton, and proton means first in Greek. Now, this guy received a Nobel Prize in Chemistry in 1908. And whatever I have told you right now was done after 1908. Generally, when you get a very good prize, you stop working. This guy started working after he got that Nobel Prize. And he got that Nobel Prize in Chemistry. And let me tell you a very small story about it. He was a physicist. If you had gone to his office, it was written PhD in physics, Ernest Rutherford, this, that. So when he got the Nobel Prize in Chemistry, he initially thought that he wouldn't take it because he thought that it's a big shame to take a Nobel Prize in Chemistry when he is a physicist. But somebody told him, "यार Nobel Prize मिल रहा है, ले लो. बाद में कोई देगा नहीं तो." So he decided, okay, ठीक है, ले लेते हैं. So he took the Nobel Prize. And when he took that Nobel Prize, he was still offended and he was not happy with the chemistry thing. So at the Nobel Prize banquet, he said that he had done a lot of reactions in his laboratories, but the fastest reaction that he has ever seen is his own conversion from a physicist to a chemist. And he is the only fellow in this entire story who was a physicist and got a Nobel Prize in chemistry. After this, once the proton was discovered, the electron was discovered, it was decided that the proton and electron has empty space in between. Everybody thought that the matter of the atom is settled, the experimental modeling is done, and now let us move on to find the theoretical data for this atom. And the next fellow in our list is this guy, Niels Bohr. He is from Copenhagen, Denmark, and he was influenced by this fellow Rutherford. So you can see the chain. First Thomson, then Thomson student, then student's influence. Now Niels Bohr was a thorough gentleman and he was such an intelligent fellow that when World War II started and Germany attacked Denmark, the first few persons who were taken out of Denmark were the king of Denmark, the princess of Denmark, and Niels Bohr. Because Niels Bohr was so much important that once he reached London, he was immediately taken to New York. This guy was the chairman of the Atomic Commission, which was making the atomic bomb. And when the atomic bomb was created, he said to Harry Truman that he doesn't believe that it should be exploded. So then he was removed and Enrico Fermi did the last rites to the bomb. So Niels Bohr improved the planetary Rutherford model using Max Planck's theory of radiation. This guy was also influenced by another famous scientist of his time, a man whom all of you know, Albert Einstein. The Rydberg's formula that you will see in later age, it shows that the hydrogen atom has 5 different spectral lines, whereas the hydrogen atom has only 1 electron, and spectral line for hydrogen should have been only 1. So no atomic model was able to solve it. So Niels Bohr said that I will give you 4 postulates. which can solve this problem. The first postulate was the electron will revolve around in circular orbits. The orbit of the electron will take only spatial value of radii, and in these orbits, the electron will not lose any energy, it will not radiate, and these orbits are called the stationary orbits. That is the Bohr's atomic model. More often than not, if you search on Google for an atomic model, this is the model that you will see. The energy will be definite in a stationary orbit. Will not go into the mathematics here. And he also gave the Bohr's quantization law. For doing all this, he got a Nobel Prize in 1922. So the atomic model, electron got a Nobel Prize, the guy who found proton got a Nobel Prize, and now the atomic model has been defined in a way, and another fellow got a Nobel Prize. So we have 3 Nobel Prizes now. Let us move on to 2 very interesting characters from Germany. This first fellow is Alvin Schrodinger. And in physics classes, he is popularly known for this particular thing called the Schrodinger's cat. If you see, you can see the Schrodinger's cat is either alive or dead. The Schrodinger said that at any point of time, you cannot find out whether the cat is alive or dead without opening the box. And this is a very interesting problem. And well, when I was in Pune, the cat in our department was called the Schrodinger's cat. And it was named by one of our theoretical physicists. He said कि यार बिल्ली है तो उसका नाम सिर्फ Schrodinger's cat ही हो सकता है, और वो यहाँ है या नहीं है मुझे समझ में नहीं आ रहा है. So well, we will not go into Schrodinger's cat now. Erwin Schrodinger found a new theory called the wave theory. According to him, all electrons behave like waves, and when 2 electrons come together, their waves will overlap each other and they will form a standing wave. This is from the wave theory. And he also said that instead of Bohr's fixed orbits, I actually don't know where the electron is, but the electron is somewhere around the nucleus. That is what Schrodinger said. And he said that it was not definite, and it was some probabilistic location at which the electron is present. He called that as orbital. You will learn all about these orbitals in detail when you will reach, I think, class 12th chemistry. Generally, physics people don't deal with orbitals that much. We do it more mathematically, but you will learn more about orbitals when we will reach chemistry. Now, the second guy is this fellow. His name is Werner Heisenberg. Werner Heisenberg received the Nobel Prize at the age of, I think, 32 or 33. That is our age, I think. And we are doing nothing. So you can understand how great that guy was. At the age in which we are, he got a Nobel Prize in physics for something which he did for his doctoral thesis or something. Now, Heisenberg is another interesting fellow. Let me tell you one story. During the entire period of World War II, 2 groups of spies always followed him. The German spies, also the American spies. The American spies thought that he is working for Germany, and the German spies thought that he is working for America. Because it was thought that anybody in the world who can understand atom and can break atom to form energy is this guy. No other fellow can do it. Well, to everybody's disappointment, Werner Heisenberg decided that in the entire period of the World War, he won't look into physics at all. And he didn't look into the atom, and thankfully the atomic bomb didn't came from this particular guy, because I would have been heartbroken. He's one of the fellows I like the most. Now, he gave one of the very interesting principle called uncertainty principle, which says, if you know the position, you will not know the momentum, and if you know the momentum, you cannot know the position. That is, अगर आप दौड़ रहे हैं, तो हम ये तो बता सकते हैं कि आप कहाँ हैं, लेकिन आपकी स्पीड नहीं बता सकते हैं, और अगर आपकी स्पीड बता दी तो हम ये नहीं बता पाएंगे कि आप कहाँ हैं। तो इस कॉम्प्लिकेटेड प्रिंसिपल से उन्होंने ये समझाया दैट it is not possible to tell the position of the particle, and in our case the particle is the electron. So he said the electron will be present somewhere, and he said that the electron can be described through a probability distribution. A probability basically means exactly at that point, somewhere in that region. So according to him and according to Schrodinger, a new model was created. The model on your left, at the center is the proton, which was founded by Rutherford. And the blue portion that you can see is the cloud in which the electron may be anywhere. For our help, there is a dotted line also. So if Bohr would have been the fellow to explain this model, he would say that the electron is on the dotted line. But Schrodinger and Heisenberg won't say that. They would say that the electron is somewhere in any of these blue points. And according to this model was created. The model was also called the quantum mechanical atomic model. I believe you will learn more about it when you will pursue a course in physics. Heisenberg received the Nobel Prize in 1932 at the age of 31, and Schrodinger received in 1933. So now the atom has 5 Nobel Prizes. So everything was said and done. We can say that now we have everything. We know that at the center there is the proton, at the outside there is an electron. We also know that the electron has some orbits, but those orbits are not fixed definite orbits, but probabilistic orbits. So we can say that we have known everything about the atom and our job is done. But in this field of atom, every time you think that I have finished it, a new thing comes up. In 1930, 2 German physicists were doing some work with alpha particles, and they found out that they have an uncharged radiation which can penetrate lead. And they thought, यार ये तो नया कुछ आ गया, something new which is not proton because it is uncharged, it is not electron also, and it has lot of energy. So now 2 people, Irene and Frederick Joliot Curie. I hope you must have heard about Marie Curie. Irene is Marie's elder daughter, and Frederick is Irene's husband. They were 2 famous chemists, and they were also working with this radiation. And they said that these are possibly gamma rays. But gamma rays require a lot more energy than the energy that was present there. And this idea was dropped. And one more fellow, a physicist called Ettore Majorana, he said that possibly we are looking at another particle. Proton is done, electron is done. Now possibly we have a third particle now, and we must look into it. Before I go forward, let me tell you one interesting fact. J.J. Thomson had a Nobel Prize. His son had a Nobel Prize. Niels Bohr had a Nobel Prize. His son also had a Nobel Prize. Similarly, Marie Curie had a Nobel Prize. Her daughter had a Nobel Prize. Can you please tell me other parent-sibling pairs who also have Nobel Prizes? Let me repeat again. Thomson, father had a Nobel Prize, son had a Nobel Prize. Similarly, Bohr's father had a Nobel Prize, the son had a Nobel Prize. Marie Curie had a Nobel Prize. She had 2 Nobel Prizes actually, and her daughter had a Nobel Prize. So which are the other parent-sibling pairs who had Nobel Prizes? Which fields? And if you can also find out which year, it will motivate you further. So that is a task for you. So this young, handsome gentleman called Jimmy Chadwick or James Chadwick, he looked onto the issue of Majorana, and he said, "Ki pakka there is a third particle and let's do experiment on it." And again they were back to the Cavendish laboratory in Cambridge, where proton was found, where electron was found. And this is the place where Chadwick junked the gamma ray hypothesis and found a new particle. The particle he found had the same mass as proton and had no charge. And in this case, the energy was also correct. He named the particle neutron. So you see, Cavendish laboratory found the electron, the proton, and eventually the neutron. Well, Jimmy Chadwick also received the Nobel Prize in Physics in 1935, and you can see the citation, only 5 words, the discovery of the neutron. Now, why we chose this topic? The first thing is we are all made of atoms, and we are required to know that how this atom came into here. You may say that the story has ended. Yes, the story has ended from my part today. We have arrived out our 3 basic particles, the proton, the electron, and the neutron, as we all know. But let me tell you, the story has not ended actually. The story has just begun. If you have a book of particles, the first 3 pages will be electron, proton, and neutron, and then you will have thousands of other pages in which there will be thousands of other particles. Where we can find these particles? Well, it is, those particles are called nuclear particles. Some of the particles we will name here. You might have heard about some of them. You might have heard about the famous Higgs boson. So there are different kind of bosons. One of them is the Higgs boson. Then there are W boson, Z boson. There are different particles called gravitons. These are all part of the nuclear family. These are the particles which you have to read. In 1950s, the atom was subdivided further. The proton was subdivided into more particles. The particles were called quarks. So you can read about those particles as well. There are a lot of other particles. So before we end this entire series, we'll look into one particular medallion which all of these people get. Lot many people are getting. You won't believe only one single Indian has got it. Few of them got as foreigners. They were Indians, but they got as foreigners. But only one Indian got it as an Indian scientist. That is another task for you, that who is the fellow who got the Nobel Prize in Physics as an Indian. So this is the atom that we have right now. This is the Nobel Prize, which you will receive if you do well in physics and chemistry. If you do find a new thing, this is the Nobel Prize that you will get. Thank you for your time. Thank you for your patient listening. I hope you will keep your interest alive and you will.
Rabindranath Tagore.
Huh?
Rabindranath Tagore.
Sir, C.V. Raman.
C.V. Raman.
Yeah, the
C.V.
answer
Raman.
is C.V. Raman.
C.V. Raman.
Rabindranath Tagore
C.V.
got it.
Raman.
C.V. Raman.
C.V. Raman.
Yeah,
C.V. Raman.
Correct.
Sir, C.V.
Correct.
Raman.
Sir, C.V. Raman.
C.V. Raman.
His nephew also got it, but his nephew got it as an American citizen. I hope one of you will get it, or all of you. Govinda, are you there?
Yes, sir. Thank you very much for this wonderful session, much required session for these kids. Shall we go for the quiz? After that, we will have some interaction.
Sure. Why not?
Right. So students, get ready. I am texting one address in the chat box. You can open that link in your browser and you can attempt a quiz. I will give you 7 minutes for this quiz. See to it, copy it, and open in your browser and attempt it. Right now there are 67 participants. Few UG students are also there.
Okay.
First year UG students.
They are from your college or they are from Nagpur University?
Our college, Bajaj College of Science.
You can tell them about the Nagpur University's initiative,
Yes, yes,
the Article Menu E-Shiksha.
yes. As we have gone autonomous, we have different exam schemes and all. Curriculum is also a little bit different. So we are also providing them all the things
Key content.
whatever is required.
Okay.
Yes. Quizzes of 12 questions. I'm getting submissions now. We have got 24 submissions till now, in which I can see maximum score is 10.
That's good.
Thirty-six students have submitted their quiz, and I think they will be available for interaction. If you have any question, then just raise your hand and you can ask your question one by one. Yes, students. Nakul Vora, you can ask your question.
Sir,
Switch on your
it was a
switch on your
Sorry.
camera so that we can see you. Yes.
There was a connection problem, so sir, I can't. Sir, I can't go. Sir, will you please sir tell where to go?
Check the chat box. Copy that in the browser.
Hello?
Right. Then quiz will get open. Attempt the quiz and submit that. Ojas, you can ask your question.
So,
Yeah.
so my name is Ojas and I have a question that what are basically alpha particles and beta particles?
Okay. The alpha particles are basically the nuclei of the helium atom. So they have mass of 4 and charge of 2, positive 2. Whereas beta particles are of two flavors. Beta particles are either negatively charged with no or negligible mass, and they can also be positively charged. Those are called beta plus particles. Generally, when we say beta particles, we mean negatively charged particles of about electron-like mass.
Okay, sir.
Okay.
Next question, Krishna.
Sir, my question is that if in a chemical reaction it takes between electrons, the electrons change from one atom to other. But if we somehow manually do the exchange of protons, then what would be the result of that?
Manually exchange protons.
No, sir. Chemical means by some process
Mhm.
like passing through X-rays and like some process, and if we change the proton of the atom, then what would it result be?
Well, chemistry or the chemical reactions are all dependent on electrons. In chemical reactions, protons don't participate. When protons participate, we call them as nuclear reactions. And for that, high energy is required, and in that, two protons can interact. Is that fine?
Yes, sir.
Next, Vanshika. Krishna, you can mute yourself.
Good afternoon, sir. So my question is, has anyone ever seen atom or just they put up theories of atoms?
Now you can see the surface of the atom actually using an electron microscope. I don't have the photographs right now, but you can search it on Google. You will find out SEM photographs for atom surface. You will get it.
I can share something
Okay,
from
sir.
my side.
Yeah. But yes, we have not seen the nucleus yet because we don't have that wavelength available yet. 10 to the power of minus 15 meters is something which we don't possess right now. But yes, 10 to the power of minus 10 meters is very common right now.
So, can we use the nano? It was the nano microscope, so which can see the nanoparticles also.
Yeah, nanoparticle microscopes are basically the electron microscopes. See, the optical microscopes that you see in your lab use light, for which the wavelength is about 10 to the power of minus 7 meters. So you can see things up to the range of 10 to the power of minus 7 meters. Most of the nanoparticles come in this range, so many particles can be seen through these microscopes also. But if you have particles smaller than that, you can use an electron microscope. For electron microscope, the wavelength range is about 10 to the power of minus 10 to 10 to the power of minus 11 or 12 meters. Is it fine?
Yes, sir.
Okay.
Next, Abhinav.
Sir,
Yeah.
so in that Rutherford coil gold. So 2 minutes. In that Rutherford coil experiment, the ray just one that which
I'm sorry I couldn't hear you.
Hello, sir,
Hello.
can you hear me?
Yeah, I can hear you right now.
Sir, in the Rutherford cold fall experiment, the rays which are shown, that are which rays or simple light rays?
No, those are alpha particles. Those are not light rays, those are alpha particles. Those alpha particles were bombarded on a thin film of gold. Like light is composed of photons, alpha particles are also a kind of particles, so you get a ray of alpha particles. If you see the diagram again, you will see that there is a radioactive source over there, which is emitting those alpha particles.
Thank you, sir.
Okay.
I have shared the scores in the chat box. You can check your score. Yes, next question. Anjali.
Hello, good afternoon, sir.
Good afternoon.
Yeah, sir, my question is that Ernest Rutherford have discovered proton or Goldstein?
Actually, lot many people were working over there, and in some cases it is credited to Goldstein, some cases it is credited to Ernest Rutherford. It was basically a joint effort at that time, and in many books, the book that I followed credited it to Rutherford. But if Goldstein is mentioned, it will not be wrong. In any experiment, a single person was not responsible for the discovery of anything. Like if you have seen the Nobel Prize citation of J.J. Thomson, it is said that he has been given the Nobel Prize for the work of his on electricity. And similarly, only Chadwick is the person who got the Nobel Prize for discovery of neutron. Generally, it used to be a group work. Yeah, you might be right that Goldstein was also there.
Next question, Kapish.
Thanks, sir.
Okay.
So, if we invent a more powerful microscope, can we see a particle smaller than atom?
Yes, certainly. Certainly you can do that. And right now, somewhere around the world, somebody is 100% working on that he can find a microscope which will look at that range. The problem is that we right now don't have a particle or a contender which can have wavelength of that range. Electron, when accelerated, can be accelerated up to 10 to the power of minus 12, 10 to the power of minus 13 meters, but it has not been possible to accelerate it up to about 10 to the power of minus 15 meters. Once it can be done, and it will, if it starts showing faithful results, we will be able to see the nucleus also.
Thank you, sir.
Next question. Again, Ojas want to ask something.
So,
hello.
Yes, Ojas.
Hello.
Yeah.
So I have a question that as they are saying that quarks are there, means protons and neutrons are made up of quarks.
Yes.
Sir, so on which basis they have given that protons and neutrons are made up of quarks, as they were not able to see inside nucleus also?
Absolutely correct. Very nice question, Ojas. Very nice question. Can I ask you one question?
Sir.
Can
Yes, sir.
Have you seen air?
Yes. No.
Then how do you know air is there? You feel it?
Yes.
Similarly, in case of nuclear particles also, sometimes we don't see it, but we see its repercussions, the results that is there. And that is how we found out that it is made up of quarks. because it was showing those properties. That is how the concept of quark came out, but we haven't seen the quark yet. You are correct about that. Possibly someday we will, maybe you will. Would you? Ojas?
Yes, sir.
Maybe someday we will. Would you like to work on this field?
Yes.
Sure. Good.
Vanshika, go ahead with your question.
Thank you, sir.
Sir, if we have not seen the atom yet, then how can we say that these elements possess these atomic number and so on? We keep on giving atomic number to elements. How is it possible then?
Again, the same answer that I gave to Ojas, that generally before you see something, you see its effects, and according to that, as the atomic number changes, you see certain properties, and you can observe those properties, and according to those properties, those atomic numbers are provided. That is how atomic numbers are provided. You are correct. Without seeing, we are doing it, but it's not without seeing. There are two kinds of seeing. One is you see it, and another is you understand it through other effects. Like, as I gave you the example, like even right now, can you see light?
No.
Can you see a photon?
No.
That means you don't accept light, or you don't accept photons. You do, right?
Yes.
Because you are feeling the effects of the photon on your eyes, and that is why you know that photon is there. Similarly, we see the effects of the atoms, and then we say that these atom is this, that atom is this. But you are correct. We have not seen the nucleus of the atom yet, and even the atomic structure was seen about 40 years ago only.
So, sir, how was the atomic number for the first time found of any of the elements?
The first time it would have been very difficult, but in science we always do one thing: we always compare. So one comparison was available was hydrogen. We haven't yet found anything lighter than hydrogen. So if you assign hydrogen to be 1, anything which will be twice its atomic number is helium. Thrice its atomic number is lithium. That is how it is done. You will always require a reference.
Okay, sir. Thank you.
Okay.
Yes, Lohia, you can ask.
Sir, when two atoms come closer to each other, do they repel each other?
They
Repel each other.
They repel each other. Well, they should, but inside a nucleus, there is another force called the strong force, which is always attractive in nature. And that is why the electrostatic repulsion is subsided, and they come closer and form a unit. In the there are basically 4 kinds of forces: the gravitational force, the electromagnetic force, the weak force, and the strong force. Inside the nucleus, the strongest force is the strong force, which is always attractive in nature, and hence all the protons and neutrons are bound to each other. That is why you don't see the atoms falling out.
Sir, what will happen if this force will get disappear? It will not work.
Yeah, got it. It will see. I believe you might have, and you know Newton's laws. Everything remains in that state until and unless you apply another opposite force to it. So if you give an equal and opposite energy to it, you can break the nucleus. The energy in which the nucleus is bound together is called the binding energy, and you can break it, and it is done regularly. The atomic bomb or the nuclear power plant works on this very principle that you are asking.
We'll take last 2 questions. Next is from Satvik. Satvik, you can ask.
Hello, sir. Good morning.
Hello.
Yes. Go ahead.
Hello, sir. What is the use of gold foil in alpha radioactive experiment?
Oh, the aim was to have a stable element there which will not get radioactive, because when you bombard a radioactive particle onto some other particle, there is a chance that the second particle might get radioactive very soon and it will start emitting particle on its own. Gold is considered to be quite inert to that phenomenon, and that is why the gold foil was selected. The role of the gold foil was to provide atoms.
Sir, but silver foil cannot be used for that.
Yeah, silver foil can be also used, but possibly Rutherford liked gold better than silver.
Yes. Thank you, sir.
Okay.
Bhavik. Yes, Bhavik, you can ask. We can't hear you. Krishna, you ask your question.
Sir, my question is that electrons revolve around atom or not, and if they revolve, then what is the speed of the electron that revolve around atom?
Good question. Electrons do revolve around the atom. We just don't know the orbit. And I'm very sorry, I don't know the speed of the electron. I'm very sorry about that.
And sir, what is its direction?
Oh, direction. Means you want to know whether it is clockwise or anti-clockwise?
Yes, or means it randomly rotates or in a fixed path.
No, it doesn't rotate in a fixed path. It remains in a probabilistic position. Depending upon the pull of the proton, it stays at a distance defined by that pull.
And sir, what is it, anti-clockwise or clockwise?
I'm sorry, I have no idea about this, but it's a very interesting question.
Sir,
Yeah.
electron speed is 2,200 kilometers per second.
2,200 kilometers per second. Kapish has got the answer. Does it show the clockwise and anti-clockwise direction as well?
I don't know that.
Yeah, I also don't.
So can I tell?
Yeah, go ahead.
So in one orbital, 2 electrons are there, and if one has clockwise motion, then the other one must have anti-clockwise motion.
Okay, that is good.
Sir,
But
they don't.
I think you are talking about the spin. You are not talking about the direction of motion, because if one goes clockwise, another goes anti-clockwise, they will hit each other.
Yes, I want to see that.
It won't happen, but what you are talking about is spin. Well,
Okay.
there was a girl who, Govinda, there was a girl who asked about the Goldstein question. I don't remember her name.
Anjali.
Anjali, yeah. Anjali, if you are hearing,
Yes, sir.
Goldstein and Rutherford both worked on it, but it was Rutherford who named it. Basically, proton is the nucleus of the hydrogen atom. That is, hydrogen atom minus the electron, or the H plus ion, you can say. So Goldstein was the first to work on the H plus ion, and Rutherford was the first person to name it. Is that okay?
Yes, sir. Thank you.
Okay.
We'll take last question from UG student. Yes. Sarvang.
Hello. Good
Hello.
afternoon, sir.
Hello.
Sir, how the wave nature of electron can be determined?
Wave nature, see, when you go for the wave nature, see, you cannot see the waves as such, but when the standing waves are formed, you get energy nodes and antinodes, and you can observe them. That is what the wave nature of electron is: energy nodes and energy antinodes.
So stationary wave produce होती है उसमें?
ये स्टेशनरी वेव ही है, लेकिन जैसे आपका जो आपने जो वेव मैकेनिक्स में जो स्टेशनरी वेव पड़ा हुआ है वैसा ही वेव तैयार होगा, लेकिन क्योंकि ये इलेक्ट्रॉन की एनर्जी की वजह से तैयार होगा तो हमें एनर्जी नोड्स और एनर्जी एंटी नोड्स मिलेंगे। स्टेशनरी वेव्स इस वजह से उन्हें स्टेशनरी वेव्स कहा गया।
Yes, sir. Thank you, sir.
Okay.
Thank you very much, all of you. Thank you very much, Subhashish sir, for sparing your time with the kids.
It was all
future also, if the same condition will be there, like if they will extend this lockdown, then I will ask you again with some another topic.
Sure.
So I would remain thankful to you, but I can definitely ask sometime from you. Thank you very much again. Kids, stay at home and just wait for the next webinar on Wednesday. Bye for now. Thank you very much.
Sir, should we write our attendance?
No, we got your attendance through your test, right? Okay. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir. Bye, sir.